Hello everybody, welcome to this vlog. My name is Satya. Today I'll be discussing about symmetric cone NAT. In the previous vlogs I have already discussed about what are the different types of NAT. So I will put a link to that vlog or video in the description box. Please refer to that. But in this vlog I will discuss only about symmetric cone NAT. So in symmetric cone NAT, as I specified, it is one of the NAT types and it is very restrictive, right? Each connection is treated as unique. So what I mean by unique, I will explain further. But before going into that detail, I would like to highlight that if you are using symmetric NAT as part of the residential router, and if you try to use peer-to-peer applications like Skype, Zoom, then it will break it, right? No matter what, there are different technologies that have come in which try to resolve this problem, but it will create some problem or the other, right? Because it is very restrictive. To understand how it restricts Skype and Zoom, let's understand what exactly is symmetric cone NAT. So for example, if LAN host 1 with IP address 192.168.129.14 sends a packet to a public server, which is a DNS server with IP address, public IP address 8.8.8.8:53, then private source IP address, which is 192.168.129.14 will be and with a private port 1053 will be translated to a public IP address 201.201.201.201. For example, I am just quoting it as an example, and the public port will be 65001 for connecting to a DNS server with a public IP address 8.8.8.8:53. If, for example, same LAN host 1 sends a packet to another server which is having public IP address 1.1.1.1, for example, and the public port is 53, then the same public IP address and different public source port will be used. That is, same public source IP 201.201.201.201 will be used, but the public port will be 65002. So we can't predict what will be the public source port, right? Every time it keeps changing for each session, even though it comes from the same LAN host 1. So how it breaks this applications like Skype is, so applications like Skype, when they send some new data through different inside apps of Skype, in Skype there might be a lot of inside apps, right, which might use different port, then it will be blocked as this port was not negotiated earlier during setup. Due to source public port created each time in peer A to peer B communication, if peer A initiated connection, then peer B will find it difficult to initiate connection, as connection will use new source public port, and this mapping won't exist in peer A NAT router. So what we are trying to say here is, in peer A to peer B communication, if peer A initiated connection, it will establish some mapping of source port to public port, right? So that might be somehow predicted and given to peer B. If peer B application like Skype, inside that there is one more application, like you want to send some picture, if it uses different port, then that port will be blocked by the peer A NAT router, because there was no because this port was not negotiated, and symmetric NAT creates a new port for each session being established. So this is the problem of peer-to-peer communication in symmetric cone NAT. To avoid it, usually most of the NAT routers, home routers, use port address translation, where only port is translated, right? And it's not that restrictive. But in symmetric cone NAT also, there are different techniques by which you can avoid this problem of port being predicted earlier or use relays NATs, right? To some of the technologies that can resolve this peer-to-peer communication problem in symmetric NAT or stun, turn, and universal plug and play. These are the topics which I will discuss in the next session, right? So if you have not subscribed to this channel, please subscribe to this channel, leave a comment if you have any questions, and like the video if you like the content that I just discussed. Okay, thank you, bye.